Let me now introduce you to this beautiful idea of recursion. And once again, we're going to use our book analogy. So again, I imagine I am trying to execute some function by reading these instructions in this instruction manual, and once again I get stuck and I don't know how to solve this. I say, what's this? I don't know how to solve it. So last time we had this other book, this helper book, that gave us the answer. The beautiful idea of recursion is that, well, the answer might be available earlier. After all, there are previous pages in this book, so maybe the book itself is a helper for you. You don't need to go to a different book. So once again, you take your question and you treat that as the argument to the helper, but you look up the answer in the same book. You call this same book and treat it like the helper function. So somewhere over here, the answer might be available. Now once again, you take that answer and return back to where you were, now that you know how to solve that point that was getting you stuck. So once again, this is just an analogy. It's important to look at this in code. So first, let me give you an example of a function which we could write in this self-help or recursive style. So I give you a natural number n and I want to calculate the sum to n, meaning the sum 1 plus 2 plus 3 all the way up to n. Now, what I can observe about this sum is this very nice property, right? So all these numbers 1, 2, 3 all the way up to n, suppose I break the overall summation into two parts. Firstly, the summation up to n minus 1 and then plus n. Now, this stuff inside the brackets should look familiar to you. This stuff inside the brackets is just the sum to n minus 1, and so I am saying that the way you solve this complicated problem, what is the sum to n? Well, firstly, you use a helper function that just calculates what the sum is to n minus 1, and then once you have that answer, it's very simple. You just have to add n to that answer. So in Python, this might look something like this. So simple. To calculate the sum to n, calculate the sum to n minus 1 and add n. Now, if looking at this code, or indeed looking at this mathematics, makes you feel a little bit uneasy, that's a good thing. It's not so simple. And to show you why, let's go to Python Tutor and look at what happens when we try to run this function. We'll calculate the sum to 4, and we know the answer to that. That's 1 plus 2 plus 3 plus 4, which is 10. Let's see if Python Tutor can tell us the answer is 10.